Hey guys, we finally got that EIGRP network configured. Router 2 can now see routes that are being sent from router 3. It can also see routes going from the OSPF side of the network from router 1. Now, let's configure the route redistribution so router 1 can talk to router 3 and vice versa. Let's get started. Okay, so we're gonna test this real quick. So router 2 ping 10.0.2.1, okay, and 2.2 and 2.3, okay, and then let's move this over a bit, and it's 3.3. Oops. And that is the switch 4 we already put up, that 10.0.3.3, which we did not put an IP address on. So I should have. So let's do that real quick. That's switch 4. Okay. Oops. Okay, and now it goes through. Now that we got that IP address on VLAN 40. When you're rushing through things and trying to get things done, you end up missing stuff. If you look here, I'm going to show my topology. If you look here, I have a overview of the IP addresses. And I actually have it's funny, I actually have the IP address specified on that switch, but because that's an access switch, I'm really worried about that redistribution. I forgot to put that IP address on there. Plus, it was a last minute add-on within the network. So, anyways, so router 2 can get to switch 4 and switch 3. No problem. So now, let's go to switch 3, which is this one here, and we're going to do a ping 10.0.3.3. We're going to ping the switch 4's IP address. And it doesn't look like it's going to go. Okay, so we're going to do a trace route 10.0.3.3. We're going to see where that stops at. Doesn't get anywhere. Why doesn't it go anywhere? If you know, leave a comment down below. If you don't know, here's your answer. Oops. So we're going to go to switch 1, and we're going to do a show IP route as a whole. So right here is the whole IP routes, all their IP routes. So we have the 10.0.1, 10.0.2, 10.0.3, and they're all directly connected. The only one that's not directly connected is the 0.1, which is via 10.2.0.2.1 out VLAN 40. And that's the router. Gateway of last resort not set. So what's happening is that packet's coming into switch 1 because switch 3 doesn't have routing capability, so it just shoots it across its trunk port. Switch 1's like, I don't know where it goes, and just drops it. So to get that going, we're going to do a config T. Okay, so we did an IP route to saying all networks go out 10.2.0.2.1. So we do a show IP route. Gateway of last resort 10.0.2.1. So what that's going to do is say, hey, look, I don't know where it goes, so I'm going to shoot it over to 10.0.2.1 and hopefully he knows. Okay? Now we know 10.0.2.1 don't know about it. right? But we're going to verify. So we're going to go to router 1. And we're going to do a show IP route. And nothing about 3 is listed in there, so we're going to do the same thing. Config T, IP route. And we're going to do a 10.0.1.2. And then write it. Show IP route. So now it says if I don't know where it goes, 10.0.1.2. So now we're going to go to router 2. Show IP route. Now router 2 knows about both networks, so it should not need a gateway of last resort if you look at just the routing table as a whole. Let's see if this works. So we're going to go into switch 1. Yeah, we're going to go into switch 1. No, switch 3, sorry. Let's this one here. Oh boy. Alright. So it made it to 1.2, but doesn't go anywhere else. So what we need to do is we need to have these two networks talk to each other. We need to be able to have the OSPF and the EIGRP connecting to each other. So we're actually going to cut out the prefix list and the route maps, and we're just going to do the route redistribution right now within the router 2. We're going to make those talk to each other. Okay? So what we're going to do is we're going to go into router 2, show IP route, and you can see it has all of them. So we're going to config T, router EIGRP 100, okay? And within EIGRP, we are going to redistribute, okay? So we're going to redistribute, okay, OSPF, process ID 100. Okay. Now this is where if you'd have a route map, you can take that route map and say I only want to redistribute whatever's in that route map, which typically ties to a prefix list. But what we're going to do is we're going to redistribute OSPF 100 match. We're not even going to do that. We're going to just give her a try. That right there. And then we're going to do a router OSPF 100. And we're going to do the same thing. We're going to do a redistribute EIGRP 100 subnets. So now we're going to go over to switch 1, which is 4. Oops. 4. And we do a show IP route. So, show IP route OSPF. I want to get those locals out. So you can see this route right here is the VLAN 40 VLAN going into the router 1. Or I should say router 1 to router 2. So it knows how to get from router 1 to router 2. Internal. Now you see these E2s, right? If you go up here into this, where's that? E2 right here. OSPF external type 2, right? So basically it's an external route being redistributed into OSPF a certain way. Okay? So now we're going to go to switch 2 on the other end. And we're going to see if we can do a show IP route EIGRP and see the OSPF routes. We cannot. Okay, so the OSPF in redistribution into EIGRP is not working. So let's go back into router 2. Right, so R2, which is this here. Show run section router. Okay, so OSPF into, so there's something wrong with that statement. Let's do this here. T, and then we're going to do router EIGRP 100, no redistribute OSPF 100, and then redistribute OSPF 100. We probably got to add a metric. Bandwidth, we're going to put 1,000. Actually, we're going to put 100 kilobits per second. Delay, we're going to put 1. Reliability, we're going to put 250 and 250 just because. Oops. And then EIGRP, that's 1500, the MTU size. Alright. Now let's go back to switch 2. There we go. Alright, so I just did a redistribute OSPF 100, hoping it would just grab all of them. It did not. We had to actually specify a metric going into EIGRP. So we had to specify a metric so it can calculate this distance right here, the path cost. So as you can see here, the D is the internal routes of regular EIGRP. DEX is the external being redistributed from another source, right? And you can see the administrative distance is a lot lower than, or I should say a lot higher, which means it's less likely to be chosen when it parses the routing table. So that's route redistribution in a nutshell from an OSPF to EIGRP. Alright guys, so we have both sides of the networks talking to each other. We have EIGRP running through, we have OSPF running through, and we have them talking to each other. So basically it's done. We did not confirm, so let's confirm. Okay, so now that they are seeing each other, we need to do that ping again. So we're going to do ping. Let's move this over ever so slightly. Ping 10.0.2.3. I should be able to ping that there, which I did. So we have connectivity completely across. Hey guys, so we got connectivity all the way across. We are redistributing those routes. Switch 3 connect to switch 4, switch 4 back to switch 3. So we're good there. We did not get to the prefix lists and the route maps in this video. What we're going to do is we're going to continue that into the next video, which will be coming later. If you guys need any elaboration on OSPF and EIGRP neighbor relationships and what's required to establish them and how to troubleshoot them, go on over to the playlist for packet tracers from the ground up. There'll be videos in there that will help you understand the requirements for get those neighbor relationships going. So I hope you enjoyed this video. If you like the content, please like and subscribe, and I'll be looking forward to your comments for what we've missed and what those questions were. Have a good day.